Hey guys, today we're going to be working with exponent rules again, and we're just going to be changing things up a little bit. So instead of working with bases that have that are all just letters or variables, today we're just going to switch that up a little bit so that our bases are going to be numbers. Remember, in an exponent, the base refers to the thing being raised to the power. So in this case, like this is a base 5, those are both base 5s, and that's just a squared. A common assumption, I'll do this in red because this is what people usually make mistakes with, but a common assumption that when you're working with numbers like this and you're combining the exponents is, well, I see multiplication, and so I know, one, I'm going to have to multiply 5 times 5, which is 25, and I also know the power rule when we're multiplying, I have a 2 and a 3, so that's going to be 5. This mistake, or this is a common mistake that people have. It does make sense logically because I have two numbers and multiplication, so I have to multiply them, and the multiplication rule means I add the powers. It's not the case really though. So we'll show you why that works out differently. So we're going to do expansion here. 5 squared times 5 to the 3. That's the same as 5 times 5 multiplied by 5 times 5 times 5. And if we pull it out like this, if we expand it like that, you can actually see now that 1, 2, 3, 4, 5, that would actually be 5 to the 5th, not the 25. You wouldn't actually multiply those. So this is essentially what you need to remember. When you have a number as a base, not a coefficient, coefficients are different, but a number as a base, that means that we have to treat it like we were using the variables, and we don't change it when we combine the powers. So that's what we're going to do. And I'll show you a couple examples like that. So for instance, the first example, we're just going to do something with the power to a power rule. And I'm going to use two different bases. Here the bases are 7 and 3. So instead of like x and y or n and m, we're going to use a 7 and a 3. And the power rule for this, if you have powers being raised to another power, that means I'm going to put the 3 on both of those. And that gives me 7 to the 6th. 2 times 3 is 6 times 3 to the 15th. And I can't combine those because those have different bases, right? That's a 7, that's a 3, those are different. Here, got a couple, we have a two-step thing. So we have a fraction bar, but before that, I'm actually going to be able to combine the 2's. So I have a 2 to the 3rd times 2 to the 7th. That becomes 2 to the 10th. Keep the 5 to the 6th. 5 squared. And now I can do the division rule between the two of those. So that's 2 to the 10th times 5, 6 minus 2, 4. So that would be the answer there. And down here, I wrote a kind of silly one, but this is 3 to the 3rd divided by 3. We'll do a couple steps out here, but the first step would be, well, I want to combine all the stuff on the top, so I'll just leave the bottom. 3 to the 3rd becomes 3 to the 9th, because I have to multiply those two powers. And divided by 3, well, that's like 3 to the 1, right? Anytime you have something by itself, it's just to the 1. So 9 minus 1, that would be 3 to the 8th as the final answer. There it is. And here, do another one like that. This one's just going to be division rule. It's a little bit weirder because we're dividing with negative powers. So this one is going to be 2. Negative 4 minus negative 2 is negative 2, because remember, you're subtracting a negative, so that means like adding a 2. And 7 minus negative 4 is positive 11. Now that we're here, you never want to end up with negative powers, so I'm going to make a fraction bar. I take the 2 to the negative 2, that becomes 2 to the positive 2 on the bottom, and 5 to the 11 stays on top. So that's the answer. So essentially, we're just going to be doing the same stuff, just instead of using x's and y's and other variables, we're going to use numbers. We're only going to do this for a little while. So good luck. If you have any questions, please come to my office hours at 11 and 1 p.m.